Hello. I didn't expect the room to be this full. So telling my colleagues that I'm actually a little nervous. So can you guys hear me okay? I got to eat the mic? Okay, I'll eat the mic. So my name is also Mike, and I'll be your chief security shepherd in this process. I'm going to do show of hands because I actually we can throw away slides and start just talking too. Biometrics. Anybody in the room? We got a handful. Surveillance, looking at videos. There's a lot of those. Okay, good. We're going to focus on, I'll give you some insight as to what I'm trying to get across in this pitch. And I'm going to give you a practical example from what we do on the biometric side of the house. The learnings are identical. And the reason for the learnings being identical is because training video, or training to find stuff in video and finding stuff in pictures is the same. It's the same mechanism. You're focusing on behaviors versus focusing on static things, but that's okay. I've got some of my colleagues in the room, so the hard questions are going to go to the smarter people in the back. That are actually our chief software architect, Chris Matthews, over here as well, and then our head of architecture for access control, Josef, is here as well. So again, any hard questions, please ask the people who know what they're talking about. What I do want to do is give a quick primer on AI. I'm not going to give a history. I am going to give a history, but I'm going to give you a short history. I'm not going to do the platitudes of is AI real or not. We know it is. That's why you're here, I assume. And also, I'm going to cut through a lot of the BS and just go straight to what we think is what works and what doesn't work, and stuff that we haven't seen work, and then ways that we've had to really, frankly, beat the crap out of models to make them work in the first place. So, how we got here today, we'll talk a little bit about the history. Like I said, I just want to go from a compression perspective. And the reason I want to talk about that is not to convince you in this room. If you're here, you hopefully care about this. It's to help you go talk to your bosses and convince them why what you're going to go spend some money on with different vendors that are probably here at this show actually matters. And you got to move fast. We're going to talk about moving fast a lot in this session. Pardon me. The timelines that we've seen in the past couple of years are, as a security practitioner, I'm not allowed to say bad words in this room, but they're freaking terrifying. If you've been doing this for a while, if you've been on the cyber side of the house, we had the same thing happen 11 years ago, and then I stopped doing cyber because I couldn't sleep. And then I came over to physical, and now I can't sleep again. That's a different problem. We'll do current state of play on capabilities, and we'll talk a little bit about some open source models that are being used in the market today, stuff you can go play with back at home, and some of the pitfalls that are going to go along with that. And again, Chris does a lot of stuff on the side, so come talk to him as well as me. And then we'll jump a little bit into processes that you can automate. And I'm really going to, again, I'm going to focus in on biometrics because it's what we know really, really well. We also know behavioral analysis for surveillance really, really well. So I'm going to talk about both, but I'm going to anchor it on biometrics for facial recognition because I can beat that horse until that horse comes back to life and do it 4 more times. But also the learnings are basically identical. You just need to apply them in a different way. So, in context, we all know what AI is. It's the ability of a machine to do what a human can. This is not a new concept, obviously. It's been in the market for a long time. I'm going to be the first one to say artificial general intelligence is probably BS for a very long time. And I talk to my son, who is a roboticist, about this all the time. So I've got something to stand on. But I will talk about machines getting better at tasks than humans. And when I talk about AI up here, that is the context that we're talking about. I don't know who's calling me. That is totally not important right now. And we're going to talk a little bit about CNNs and why they're important, how to apply CNNs in a vision context, and why you want to probably use either CNNs or some custom version of matrix math to apply over the layerings in both your direct image models as well as your vision models. Because ultimately, CNNs are what's going to tell you the difference between frame A and frame B. So I joke about this because it is kind of funny. There were 30 years of CNN research going on before 1997, back in the 60s. I can't remember the people that were doing the first research. Really got applied into matrix math and graph models back 15 years ago. The people that did it are, again, way smarter than I'm ever going to be, so hopefully I won't embarrass myself by talking about a small amount of what they've done. However, 97 is when, if we're all, I think most of us are in this room, old enough to know when what's his name? Kasparov was beaten by Deep Blue. That was a major shift. It scared people for about 5 minutes, and then we all stopped caring. Then you fast forward quite a bit into the future. It was around 2020 when things started to get extremely interesting. So the internet died. If those of you that ascribe to the dead internet theory, probably 5 years ago, when NLP models became good enough to replicate human language content across multiple sites and scrape. Again, I'm using my son as an example because he's not here to be embarrassed by it. This is how I teach him to look for things. Go look at another site, see if the language is similar, and then if they are, then ignore both. So around 2020 is when we saw language models actually start to take hold. That's only 5 years ago. That's part of the reason I'm concerned. 2021, OpenAI launches the DALL-E model. The DALL-E model was hilarious back then. If you were playing with it, I'll show you some pictures. It's a lot of fun. Now it's fundamentally impossible. Uncanny Valley no longer, well, it exists if you don't have the right inputs. But if you prompt properly, it is very difficult with very simple returns to discern as a human being between machine-generated content and human-generated content in the real world. And I'm going to keep coming back to that, not because I want you guys to go start using DALL-E, but because the deepfakes are real, and we're going to spend 2 minutes on that and blast forward. But more importantly, machines are better at vision stuff than humans are in a vast majority of cases. And we are bad at it as people of every race, of both genders, of all genders, of everything. We are terrible at discerning between like things in the wild until we know those things. Machines aren't. Machines don't care. 2022, OpenAI launches ChatGPT. That's the part of the new boom. I live in Silicon Valley, so therefore we can't afford to move houses anymore. And then 1 year later is when machine vision fundamentally outperformed human perception. And that was the tipping point for me personally, because we went from, this is really fun, I can go generate tons of video content and make images and goof around and like write poems and things like that, to, oh my God, this now affects my day life, my day job. So in the this is a tale of two pictures. Anybody know, if you're using DALL-E or any of the other open source models, I keep picking on DALL-E because it's the most popular. If you use any of the models a couple years ago and you said, give me an image, even with really sophisticated prompts, of a bunch of huskies pulling a sled in the snow in Alaska, you would get a garbled mess that looks like The Thing from 1977. 2 years ago. No, 1 year ago, sorry. This image was created back in the end of 2023, so about 16 months. The image on the right is cropped. I only cropped it to fit on the slide, but that is the same prompt. And it's fundamentally different. And again, if you're looking for the cues, you can tell the difference between AI-generated content and real content if you're really looking for the cues. And it's content that you understand, and it's things that you're used to seeing, and you can discern between the differences. Again, machines don't care. And part of the reason that I'm now back to not sleeping is because we're seeing the same modalities of theft with physical AI that we had 10 years ago with people writing spam emails to CFOs and dropping USBs in parking lots on painted lines, right? I can give you a million examples. Now they're funny. They weren't funny back then. But the same thing's happening now. So you've had this finance worker, $25 million loss payout because they had a Zoom call. As you guys probably know, you can do synthetic video insertion via Zoom, via virtual camera. You can feed a virtual camera of any kind. They don't actually care what it is. That virtual camera can be an AI stream that takes my voice, makes it sound like Chris Matthew and gives me cooler hair, and then suddenly I've looked like a very different human being and I can totally fake something on the other side. So that is now real, and we need to be able to discern those two. And when I'm looking at, this is going to be a unique niche space because you have to be in a forum to do that sort of thing, usually with other people the other side. There are ways that you can test these. There's technical implementations you can do to ensure that virtual cameras are secure that haven't been done yet, but they will get done eventually. But it doesn't mean that they're going to slow down. So we all thought that we had this part of the theft side of the house relatively well defined, and then we cracked open a new one last year. I think that was April March of last year. No, February last year, sorry. It was probably back in 2023. So that just goes to show it's been a couple of years now where these things are going on in the real world. So again, humans, not as good as machines as seeing images and discerning between them. So the good news is that we haven't been totally asleep at the wheel as an industry. We've kind of been asleep at the wheel, but not completely. We've been working as an industry on biometric analysis and behavioral analysis and surveillance for the better part of 15 years. We were really terrible at it for a long time. I mean, still, state of the art still is, can I read a license plate from 54 feet away, right? So that's not awesome. It's really not great, but we're getting better as an industry. And we're getting better at defining the characteristics from which we want to determine the behaviors that we need to evaluate scene to scene to apply the matrix math with CNNs to look for the differences to determine the behaviors that we're actually looking for. So there's multiple steps involved, but at least the math is well defined and the behaviors are well defined. So we've been, again, over the past 15 years, but really the last 10, we finally crossed the barrier where machine vision's been better than humans for a while at determining things, but we finally got to the point that machine vision is like world class, where at least within a gender and ethnicity in a known group, humans are no longer better than the machines that are trying to copy them. Whereas before, if I walked into a country that I knew nobody from ever in my life, it's very hard for me to actually discern between people. I'm not saying that it's just me, that's just humans. Now, the machines can do it within your own group, of your own tribe, essentially. So, and the reason I had my watch on was so I can track the time so we don't totally blow past. Commercialization for face technologies really got functional around 2014, but really 2018. And the reason for that is false negatives are kind of a drag. False positives are really, really bad. But when you get down below about the 0.2% threshold, that's when you're putting 1,000 people through a door, and 2 of those people are going to be either let through or not let through. We want to make it 0 let through and maybe 2 not let through. That's much more acceptable than letting someone through that's not supposed to be there. So you're seeing a bit of an arms race in the analysis between false positives and false negatives. We flipped that model. It's more true positive rate and true negative rate, just to make sure that people understand what we're looking for. But we finally got to that point just in the last couple of years, and even though we're down at 0.15, this leads me to the rest of the discussion. A lot of the models that you can use out there that are open source are still around 2%. And that's for face. So biometrics is probably the best defined space. The behavioral analytics space is nowhere near that. Because you've got to look for, so let me give you some examples. Actually, I'm already throwing away slides and we're not even to the meat yet. Oh, I can use the slide as an anchor point. All right, cool. So I try to look at this in the same context that we did over the past 20 years in cyber. And like I said, I lost a lot of hair during my cyber days. I was a CISO for a major corporation doing identity for vehicles. And you can imagine how awesome that was to get phone calls that somebody stole cars. So going back to that time frame and then into today, it's log, alarm, and act, right? It's super duper simple. It's the same thing in all cases. What you can automate is going to be defined by the fidelity of the detection. And the fidelity of the detection is going to be driven by the understanding of that behavior that you're looking for. If someone's carrying a rifle and it's on a school campus, that is clearly not going to be in scope. But if somebody's carrying a rifle and they're getting out of their car and they're in an area where maybe they're going hunting or they're getting their gun cleaned, I mean, these are actually legitimate things. Having grown up in a place where that was really common, we can't use those characteristics as very standard weapon equal bad. It all becomes context-based. So in the context of context, you're looking at things that are allow in and don't allow in. Access in, don't access in. Super simple, right? Firewalls, network access control, antivirus. These are either regex-based or signature-based things that I can say definitively good, definitively bad. Once you take the step past that, and even if you draw that analogy further, I'm going right to left, by the way. Take that analogy further, and you go into really high fidelity signature intrusion detection and prevention. Most companies are still running intrusion prevention as detection only and running alarms. And that is also the case when we're looking at things on surveillance and identifying behaviors. Now, the good news, if you want to call it that, of our industry is that the number of events we need to monitor is significantly lower by orders of magnitude than it is on cyber in terms of like actions, right? But if you're a security professional at a stadium, you're looking at 50,000 faces and hundreds of thousands of behaviors and multiple ingress and egress points. It's a different animal because you actually have to act in real time. And the chances of a detection leading to a physical event are significantly higher than they are in cyber when an action in a firewall leads to an actual loss event. So I said it's kind of good news. The good news is they got less stuff to worry about. The bad news is that most of that stuff's really terrible. So then on log, it's just star.star. We log everything, and we should be logging everything that we see. And I want to encourage people that are starting to use AI models to do that, not because you want to look through all the logs, but because it's going to help you train the models that you're deploying. And if you've got models that you're taking off the shelf, the open source stuff is pretty good. You're going to learn as you're deploying a bunch of different ways to use that alarm and log data to inform decisions going forward. And it's both positive and negative test cases. That's actually really, really important as we look at a couple of examples here. You're not just looking to validate your assumption on a behavior, you're also very much looking to invalidate assumptions that are incorrect. And that is probably more important, especially for, it wasn't biometrics at least, but it's probably arguably more important for most behavioral use cases for surveillance as you go looking at those. So, kind of a reverse summary here. The things that we think we can automate today with high confidence are going to be access control applications because it's a yes-no. And yes-nos are pretty easy. They're pretty black and white. When they get gray, then you have humans intervene. It's that simple. We've been joking in this industry for a long time. I'm not wearing my plastic badge right now, but we all have one as to what point I can light that thing on fire and just use my face to get into a building. Because at our own corporation, and I'm not speaking on behalf of Intel when I say this, but we have hundreds and hundreds of security personnel sitting around twiddling thumbs. And because the job is like 99.99999% of the time, we're just going to work. Like I had to pop into the office yesterday before I flew down here, or sorry, on Sunday, before I had to go to a meeting on Monday before I flew down, and to grab t-shirts, like the one I'm wearing, by the way. There's a security guard just playing Minecraft, which is awesome. I'm glad he was playing Minecraft, but I was probably one of 4 people that walked in that door that day. And it probably should be able to automate processes like that because I have a face. And I only have one face, as far as I know, and everybody else's face is different. And I guarantee that if I ran face analysis against this crowd, there's a lot of people in here, but there's maybe 100 and change, we wouldn't end up with a duplication. So anyway, automate stuff like that. Stuff that's high fidelity, that's got independent test backing. People like NIST do phenomenal testing. It's when you start getting into the other areas. So when I say automation, automation can take a lot of different looks. It doesn't have to be slam a door shut. It could be send out a security personnel or send a truck, right? So you may want to consider automating for medium to high fidelity events that you've done enough testing against, because again, the risk threshold on a physical event is much higher than it is in a cyber event. So again, it's that balance. I probably should have put a scale up here to show as an example, but I think you guys get the idea. Some of those well-defined things, fingerprint, face print, kind of voice, was voice, not so much anymore. It's got to be live though, and that's actually one of the things I want to harken back to before in 2024 when that poor finance person signed off on a $25 million check that wasn't supposed to go to those people. Identifying, now we're taking that next step, right? There's behavior and static analysis, and then is a person actually doing that thing? And is it the person that doing that thing representative of the person you're actually looking at? Because we get into the because of our industry, the deeply scary stuff of people pretending to be other people, showing up at facilities, and then getting in and doing bad things. So the prime example is face biometrics. I'm going to talk about the models that you can look at there. We obviously have product in that space. I'm not talking about our product up here. You're welcome to come by the booth and take a look. But I want to talk about some of the tooling that you can use to go start playing with it. If you're goofing around, awesome. If you're an expert in the space, you probably don't need to be in this room because you're going to know more than the rest of us, right? But if you're goofing around, there's a bunch of open source models you can start playing with today. That water bottle almost exploded on this microphone, and that would have been really embarrassing for a lot of reasons. All right, so YOLO, I'm going to talk about YOLO for a few minutes because YOLO is probably the one you want to anchor onto the most. The YOLO model is extremely well defined. It's very well trained, and it can give you accuracy for a lot of different analysis and behaviors to the tune of 80+%. 80+% isn't bad when you are looking for tailgating, when you're trying to determine high confidence of threat via emotion. It's a little bit dicier with emotion. And then it's not too bad when you're looking for like vehicle-based events and multi-person events and fights and things like that. So it's a decent place to start. I shouldn't say YOLO's decent. YOLO's way better than decent. It's commercialized through a lot of different mechanisms. But you've also got other options, Detetron, MM detection, and a few others that are out there. Again, a ton of open source models, all trained to various degrees. We play around a lot with YOLO for our own purposes, and I'm not going to get into them in too much detail here, but we do some person detection. In addition to face detection, we do some tailgating analysis. We're doing some work on behavioral analysis, and we're also looking at emotion of people when they walk up to a door. So it's kind of the chain of events, though, that I want to string together, which is when this gets really dicey. Yes, I know that it's my face when I walk up to the camera. I know with confidence that it's me and not someone wearing a mic mask, which is super creepy. Then there's one step further than that, which is there somebody standing behind me? If there's somebody standing behind me, do I have a concerned look on my face? Now, we're in the security industry. We probably always have a concerned look on our faces, but do I look more nervous than normal when I'm walking into a specific building or site? Is that person at a reasonable distance? Then you can start to do some more sophisticated things like gait analysis and body position detection. Is that person's body position in such a way that one arm is obscured and one is not? If one arm is obscured and it's right, you've got and it happens to be bent at like a between 40 and 80 degree angle, are they holding a weapon, and are they doing that to the back of the person whose face is pointed at my camera that I just said walk in the building? So again, stringing all those together is when things get super interesting and when you start to lose fidelity very, very fast, because you start with face is great, it's definitely a human dude, looks like he's aged a lot since the last time he was here, however, then step by step by step. So as you go through that, take a look at YOLO, definitely look at V5, it's very, very well baked. V8's awesome. And there's multiple modalities. You can run them on different GPUs. They're not ours. They're commercialized by a different company, but it's all open source. And then you can start looking at some of the counting and tracking applications. Deep sort, deep track. There's a bunch of them. And they have various efficacies for various use cases. And this actually is one of the biggest points I want to make, because I haven't gotten to some of the chunk of data yet. But like Fairmont, ByteTrack, again, really, really good stuff. But you start to see different fidelity in different conditions. Kind of like when you're looking for biometrics for face in the dark versus the light, right? But that problem's been solved. This slide I love. Oh, and it doesn't show up properly. Dang it. All right, so little funny story. My son he's 13, and he's awesome. There was a company local to where I live that wanted to show kids how to program for AI models. So of course he comes and asks me, who are these guys? So I go look them up, and I told him he can't go to this conference, it's class. And the reason I told him he couldn't go to the class is because in this case, they had, and it's not the image from their site, because I'm not gonna call these guys out, that would be super cruel. But they had animals, they're doing animal detection, which is really cool, it's wildlife detection. But there was a picture of, it was a pig in the background, and it was 63% confidence that it was a human. So it's like, that's when I saw that, I'm like, and my son saw the look on my face and went, what's wrong? And I said, well, is that a pig or a human? He's like, well, it's clearly a pig. I'm like, they think it may be a human. So we had a really good conversation about fidelity. My son's 13. He's a total nerd. He's just like his dad. We get each other. But the point being, if you hyper-specialize a model for a particular use case, you're going to get results for that use case. And this leads us to bias. And I'll talk about bias in astonishing detail if you guys want to later on. So if I'm looking for pink pigs at farms, because I'm looking specifically for various types, and maybe I'm looking for, I don't know, whatever. I'm looking for health and size and doing volumetric analysis to ensure that the pig's large enough so we can bring them off the farm and go to slaughter. If I go from pink pig A to brown pig B, and suddenly that thinks it's a wolf and not a pig, my model doesn't work. It's really good at finding pink pigs, but suddenly I throw in a different color pig and that pig breaks the model. And this is a real situation. I mean, it's marked up by me, but we've seen this in the wild. At the same time, the flip of that, the paradox, is that if you generalize the model to look for pigs, it's going to pick up some wolves and say it's a pig, or a person with 63% confidence that it thinks it's a pig, or any other animal, it's going to think it's a pig. And the same thing with cars. I mean, this one's great because some of my annotations fell off. You can't see them anyway, so I can say anything I want right now because it's invisible. But the annotation on the gentleman on the mobility scooter was car, because the model was trained in such a way to look for multiple wheels and differences between multiple wheels and looking for obfuscation of fourth wheel, third wheel. So if I'm looking for a vehicle and I can identify clearly there are 3 wheels, possibly 4, 3 wheels, possibly 4, obviously equals car. So now, elderly gentleman on mobility scooter who looks a lot like my father-in-law, it's not my father-in-law, suddenly a car. So you've got that fundamental paradox. You've got to train the model the right way to look for what you're looking for, but when you overtrain it, you're only going to find what you're looking for. And we can call that target fixation for AI if you want to. I've never called it that before, but as a motorcycle rider, that's hilarious to me. If anybody else rides bikes and knows the target fixation paradox when you're riding a motorcycle, you know exactly what I'm talking about. So what does it mean? Commercializing AI solutions is hard. Full stop. But it doesn't mean you shouldn't do it. And there's a lot of, like I said, the open source tooling that you've got, the data sources that are out there, they're all really, really good, especially as you start going to proof of concepts for particular modalities. And again, we get the latitude in our industry of over-rotating for alarms, because when we screw it up, people can get hurt. So saying that might be bad is way better in our space than saying that might be bad on a firewall. So you're allowed to over-rotate to higher alarm rates against lower fidelity catches. But I'm going to break this down a little bit because I just realized we probably don't have enough time to do the rest of it justice, and I want to leave some time for questions, although that might be chaos because there's a lot of people in this room. So let's do this first. So pipelining. I'm going to talk about it in the context of face again, but pipelining is pipelining. Convolutional neural networks are really simple contextually, but very hard because I'm not a mathematician. So it's graph math. You're applying a matrix as a primary filter layer on top of an image, in our case. When you're doing it on video, you're applying it between images, just to make it as simple as humanly possible. So in this case, I'm applying a detection algorithm as a first pass with what we call bounding boxes. You saw those with the pigs and the dude on the scooter. You apply the first pass detection, which gives you the bounding boxes. Those bounding boxes then give you parameters within the image that you're looking for the face. You then extract those faces. So pass 1. Pass 2, that may take multiple passes, by the way. Sometimes it takes 3 or 4 passes. Sometimes it takes a lot more. It depends on the resolution of the camera. It depends on the fidelity of your algorithm, and it depends on your training data as well. So, but let's say it takes a couple, 3 passes to get all the people in this room. And I don't think there's anything out there today that could actually capture everybody in this room. There's too many. I'd have to be using most of a data center to do that in real time. But you can do most. Then you want to do the analysis. And the analysis then takes, again, in the context of face, I need to see the pose, which is angle of face and yaw, pitch, and roll of the head. I want to look for features, and those features include facial hair, but largely they include non-biological features like glasses and hats and COVID masks and things like that. I then want to do a fork pipeline, which is why you see multiple blocks somewhere up here. That takes me to, those different forks do different things. So one fork is going to be for anti-spoofing. So in the case, in the world of facial biometrics, I need to make sure that you're not wearing a mask, like a physical mask. We have a customer doing awesome stuff, and they were testing with kids at a theme park, and those kids came with face makeup to look like Shrek, and suddenly my camera's got to determine Shrek as human versus Shrek as monster. So that was amazing. The use cases we see are all over the place, including pigs. But you've got to fork that process to go with additional CNNs to go in different stages to go look for the different things like, is it a human being? Are they wearing face masks? Do they have makeup on? Are they wearing a hat? Are they allowed in this building if they're not wearing a mask? Because we have that with hospitals. Are they allowed in this building if they're not wearing smocks? Because we have that in clean rooms at our own company. So then taking that a step further, we go to the recognition phase. And this is where the fidelity magic starts to come in. You've got to get really good with your training data to be able to determine the actual recognition of the person now in that image. Or between images, the fidelity of the behavior to see if the behavior is happening. Somebody swinging a fist looks a heck of a lot like somebody giving a hug. If you have relatively low pass CNN with relatively low frame rate, but if you do it with high frame rate and you jump too quickly, you're going to now alarm that somebody's throwing a fist, and you may send your security people over to go break up a hug. So you got to be really careful about where that applies and how it applies. And then you go over to what we call temporal adaptation, which just means is how much older are you now than the last time I saw you. We specifically do that through some training tricks of synthetic generation of aging. With cases like me, you don't need to be synthetic. You just look at me last year versus this year. But we take pictures of actual live humans, and we also do synthetic generation. But the face detection, like I talked about, it's important to make sure that you're discerning between a face and a hand, because if you're looking for certain markers that are like pink, or looking for differentiation that looks like skin with shadow, you can very easily see a face, or you can see a hand and think it's a face. So you got to have that first pass detection. That's part of one of those fork models I was talking about a second ago. The negative reinforcement, I mentioned this a few minutes ago. This is really, really important. So training your model to know that a hug isn't a punch is equally important to training to know that a punch is a punch. And practice probably more so, because what you can do is eliminate your false positives dramatically. False positives are never fun, especially false positives on face matching. If you're automating for faces and you've got a similar false positive and false negative rate, you're going to get fired. So don't do that. False negative is okay. It sucks, but it's okay. Like if you reject somebody going into a building, nobody's going to get fired unless it's the CEO, and then it's a different conversation. If you let somebody in who looks like the CEO as a CEO, that's a different problem entirely. So training against the negatives and doing negative reinforcement, it's kind of like doing QA when you're doing negative case testing, right? And for those of us that are software engineers that are on Reddit, the jokes are everywhere. So, secondary case. So the data set that we used has 1 million different bounding box examples that we tracked to find the faces. And it's because the bounding boxes, again, because you're looking for a small portion within a frame, and then within that frame, you're looking at discrepancies across pixels. We've got to train against both faces and across bounding boxes for said faces, because you need to have fidelity down to, is it a small, in a big room like this, somebody in the back of the room looks a whole lot different than somebody in the front from a camera's perspective. So determining a face in those bounding boxes is really important, and then that was just a data exercise gone wild. We had 1 million plus bounding boxes. I think we probably hit 2.2 at one point. We retrain all the time. That's another thing I didn't put in here. It's never one and done. You're going to tweak your algorithms because you're going to get smarter, and then you're going to break something. And then that person that you broke it for is going to call you and yell at you and tell you that your product is broken, when in reality, we will then call back and say you used it wrong. because we're engineers. Don't do that, by the way. I got into an argument with a very large company in Japan over this recently. So you've also got to look for stuff on the face. And my wife went to an event the other night, and it was a 70s thing. I was out with the flu, so I couldn't go, but she showed up, and she wore these fake eyelashes. I didn't have a chance. I was going to run the camera against her just to make sure I could detect her versus her actual face, because these eyelashes were like 6 inches long. Totally different human being. Certain things really easy, and this is my wife, I've known her for like 20 years. Certain things are really easy to still tell if it's a person, because when you see eyes and nose structure, like with the gentleman in the bottom right, COVID mask, you can usually still tell if it's somebody you're relatively familiar with. But you lose fidelity very quickly because the markers on the face disappear. We use about 80 markers in how we do analysis. Some people use more, some people use less. It matters, but you guys determine how you want to do it. And then different features you need to detect as well. Again, if you're registering people, thank you. If you're registering people to be in a system, then you may want to register them with sunglasses on because it's an outdoor environment. But it's really hard to get eye markers when you've got polarized glasses on, because infrared only passes through polarized light in 90 degrees, which is the definition of polarization. So the use cases that you have to evaluate when you're doing the training are really important. We had a case, since I do have a couple minutes more than I thought, we had a case where we're working with a company in Dubai, and we trained our model to work in total darkness and light, so we're pretty good at doing both. But we really tested when people with darker complexion are wearing really bright clothes and very bright sunlight. Suddenly we're coming up with the opposite, again, it's negative testing, right? We're coming up with opposite test cases that we hadn't evaluated before. So we learn too. It's not like we know everything here, we learn every single day. And my customers tell me this all the time. Training data. So you gotta have a lot of faces, and they've gotta be real faces in the wild. So LFW, live faces in the wild, will be a data set that you probably heard about. There are kinematic analysis tools that you can use as well for gait, as well as for behavior when walking. People that are carrying heavy loads have a different behavior in walking than people that are just walking normally. People with injuries walk differently, et cetera. So we actually did a bunch of stuff on physical therapy and biomechanics as well. So we learned a lot in that space. And you apply those same learnings to behavior. People walk differently when they're nervous. They act differently when they're nervous or they're frightened or they're angry. You can use speed detection as one of your tools. You can use, when you're walking faster, I can't remember I'm not a kinematicist, sorry, the person we had on staff taught me more than I ever knew. Your legs move at different angles when you're walking fast, when you're nervous and you're angry, versus when you're moving fast for the purposes of exercise. So training your tools against those specific use cases, again, you don't want pig versus wolf, but you can then look for those exact behaviors and target against them. But it's data, and it's a metric ton of data. You need millions and millions of things to train against. We then took that a step further and went with synthetic data. So for our facial biometric analysis, we took 1.2 million faces. It took a long time to train it. And we retrain every time because we're sadists that way, but the model continues to perform that way. The synthetic data then lets you take an individual human face, as long as you've got enough field of view against the face and you've got the right pose, you can repose estimate against multiple pitch, yaw, and roll scenarios. So now I can tell you exactly my face from like a 25% cut against a cheek, right? So taking those other, whether it be face or other things that you're looking at, and then applying synthetic modifications against those is really important to get additional context and color to get greater fidelity for that catch. Oh, sorry, we did a bunch of crazy stuff. If you look at the NIST testing data, they do a matrix of ethnicity matches, and everybody borks it somewhere. But they do a heat map basically of which models are good when trained against one data set versus looking at a different data set from a different country. So take that into consideration when you're evaluating this stuff too. And the ethical considerations. So I was joking earlier about pink pig versus black pig. People look very different. And thankfully, we have largely gotten past the point where models will misidentify across massively different ethnicities. The Chinese vendors that were doing this got really good at it because their surveillance is it's top notch, as they say, and that pushed the industry forward. So it actually, in that case, while I don't necessarily agree with the modality, it pushed the industry really hard to make sure that we can catch from multiple ethnicities within different racial subgroups, and you got to push that one really hard too. Because and again, I'm going to take that back to the surveillance model. If I'm looking for somebody who is carrying a heavy load, that might indicate they've got weapons or they've got something kind of crammed into their back, versus someone who has sciatica. Those are very similar looking things when someone's kind of like dragging a foot a little bit or just walking normally. So again, those data training and modifications are really important to make sure you're not doing accidental false positives, especially within one particular racial subgroup. And then I talked about pose and 3D landmark estimations and re-renderings. These were fun because we take the actual human face, then we do modifications, and it's everything from making kissy faces with lips to like puffing up their cheeks like a pufferfish to raising eyebrows, lowering eyebrows, look left, look right, look up, look down, and everything in between. We also apply things like we're putting artificial sunglasses on people. That makes their eyes opaque so we can't see the markers. And then you can get a bunch of different ways to evaluate and define your own thresholds against that. I'm going to skip this. If you want to come talk to us about NIST testing, come to the booth, please. I don't know what our booth number is, 32099? That's the one, thank you. So come check, well, we can talk to you about this all day long because we love this stuff. But this is the one I wanted to land on. So what we call is the discrimination threshold. The discrimination threshold, you get to define. What is acceptable to you to determine something's actually real versus not real? It's really that simple. And again, whether it's someone with a weapon stuffed in waistband versus somebody carrying their lunch and tripped over a rock on the way in and sprained their ankle, versus with faces, like, by the way, I didn't know the difference between Jamie Presley and Margot Robbie before we put this together, so this was actually pretty funny to me. But in the wild, human beings are really, really bad at determining not just similar pairs, but also identical people in different scenarios. We're much better at the latter, so it's like you can probably tell Miley Cyrus versus Miley Cyrus, but that's not something we're really good at. Machines are just better at it. So you get to define what that threshold is. Again, behavior-based, face-based, you pick. I already talked about this. I'm going to jump ahead here real quick. Oh, my pig slide again. And then we specifically then take 2D data and do 3D estimation from it, as well as taking 3D data and taking 2D estimation off of that. So we can get into the science of how those different models work and whether you need infrared versus dot projectors versus rolling shutters versus blah, blah, blah. That's all stuff you can discuss later on. But there's other tricks behind that to benchmark both the behaviors and the movements, as well as the object detection. We didn't talk about object detection much in this, but that's clearly a space that is growing, especially for surveillance analytics, for package analysis, if somebody left something behind that looks like a bomb and it shouldn't be there, or other things like that. So then we did anti-spoofing. This is really kind of fun. We actually went to the extent, and this is just us doing this because we were goofing off with it, but we had to prove that our anti-spoofing model worked. So we had these $15,000 masks made by the same people that did the stuff for Mission Impossible. So they did the Mission Impossible mask for us, and we two of these are those actual masks. We applied those and were able to pass it as well. Again, because not that we've actually seen this in the wild, but we're deployed in some military installations globally that this causes coups. I can't tell you that story, but this story is fascinating to me. So it's like the far, 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 far extreme of security, but it allowed them to determine that the face wasn't moving like the face was moving. the lip movement didn't match the cheek movement because the way the mask was constructed, because it's a mask. It's not musculature, right? So anyway, that was kind of a fun one to end it on. Just want to leave you guys with that. And then if you have any questions for us, I know we're out of time here. I'll stick around as long as you need. We've got award ceremonies later. We're at the booth if you want to come chat about stuff. Our guys are really, really good at multimodality AI models, not just face stuff. So if you have other questions, Chris, Joseph, and others will be here as well. So thank you guys. Really appreciate it.